Hey, it's Mr. Arwin. We're going to solve some rational equations. These are practice problems. The first one here has a fraction on the left, x cubed minus 5x squared all over, x squared plus 4x minus 45. Now on the right, the fraction numerator negative 19x minus 90 over denominator x plus 9. So, in trying to do this, we really want to get rid of the denominator, so we want to find a common multiple of the denominator so that we can cancel them out. But we don't want to use more than we actually have to. So let's go through here and try and factor any denominators we have. So we'll try and factor the x squared plus 4x minus 45, which factors into x plus 9 times x minus 5, if I'm not mistaken. So we already see that we have some repetition in our denominators, which will be good. I'm kind of curious here as well, because if I factor this numerator, the x cubed minus 5x squared, I can pull an x squared out, and I'll see that that leaves me with an x minus 5 that I could cancel. So that's kind of unusual in some of these, but I have something that works out a little bit better. So I'm going to rewrite this thing with the reduction, so it'll be x squared over x plus 9 equal to negative 19x minus 90 over x plus 9. And now there's only one denominator. So I'm going to multiply my entire equation by x plus 9. And that's going to cause the denominators to drop out, so I will just have x squared on the top on the left and minus 19x minus 90 from the denominator on the right. Now I'm at a quadratic, so I'll pull everything to one side. X squared plus 19x plus 90 equal to 0. We need to see if we can factor that thing. I'm going to write it up here. So x squared plus 19x plus 90 equals 0. I think that's x plus 9 times x plus 10. So I get two answers, x equals negative 9 and x equals negative 10 from solving it. Now remember what I've said, you don't have to check these answers to make sure they balance 100%, but you do need to make sure they don't cause problems in your denominator. And your first denominator was essentially x plus 9, x minus 5, and your second denominator was x plus 9. And if you plug that negative 9 solution in, it actually causes it to be undefined. So you have to throw it out. But the x minus 10, if you plug it in there, does not cause a domain problem, so it should work. Okay? If you want to actually plug it in and balance both sides out, that's fine. But the x minus 9 definitely causes you to divide by 0, so you can't use it. Okay. The second practice problem we have is the fraction x over x minus 2, and that's minus the fraction 9 over x plus 4. That's all on the left-hand side equal to the fraction x squared over x squared plus 2x minus 8. So once again, we're looking for our denominators. So x minus 2 is one of them, x plus 4 is one of them because there's nowhere those can go. And on the right-hand side, the x squared plus 2x minus 8. Let's see what that factors into. Looks like it's x plus 4, x minus 2. So those don't cancel out right now. But at least I can see I only need to really multiply by two things. And that's x minus 2 and x plus 4. And that way I don't get extra stuff in my way. So when I do that, the first fraction, the x minus 2's will cancel out, so I'll have x times x plus 4. And then with the second fraction, minus 9, but the x plus 4's will cancel out, so I'll have x minus 2 times the negative 9. And then the fraction on the right-hand side, the x squared is there, but the denominator and what would be multiplying by will cancel out, both the x minus 2 and the x plus 4, so I'm just left with x squared on the right. So then I have a simple quadratic I got to clean up. So as I distribute x times x plus 4, I'll have x squared plus 4x. and then distribute negative 9 to x minus 2, I'll have minus 9x plus 18. All that's equal to x squared. I'm going to bring everything to one side and combine. Luckily, my x squareds cancel out, so it's no longer a quadratic. But I'll have negative 5x plus 18 equals 0. I'm not seeing a mistake here. So I can work on getting my x by itself. And I'll move the 18 over, divide by the negative 5, so it looks like my answer is 18/5. So one answer, but let's go back up here and see. All we have to do is make sure it doesn't cause a problem in those denominators of x minus 2. So the problem with that would be 2, which 18/5 is not. Adding 4 to it will not make it 0, so it's not a problem in any of the denominators. So we will say it works and keep it. Okay, one more practice problem. Yeah. This one here is the fraction 3 over 5x plus 1 minus the fraction x over x minus 4, and that's equal to a big fraction with numerator negative 6x squared plus 2x plus 69, denominator 5x squared minus 19x minus 4. Okay, so this is going to take a little bit of work, so let's do it. We already automatically see we're going to need to multiply by 5x plus 1 and x minus 4. And we're really hopeful that those show up in the denominator on the right-hand side. But let's go through and factor it really quick so we can review factoring a little bit, especially since it starts off with the 5 instead of just x. So nothing will come out of here, but we need two things that multiply together give us a times c, which would be negative 20, and add up to be b, which would be negative 19. After a little bit of thought, we decide that combination must be negative 20 and 1. So we will build our two factors, 5x minus, wrong button. 5x minus 20. I don't know where I got 21. Let's get rid of it. 5x minus 20. I've moved my pad over and I'm hitting the wrong thing now. Let's move it back. 5x minus 20 times 5x plus 1. And just a reminder that 5 that I put in both those places came from this 5. But I can pull a 5 out of the first one, so 5 will I throw away, will leave me with x minus 4. Nothing comes out of the second one, 5x plus 1. So basically what I've done here is just kind of shown that this denominator is made up of x minus 4 and 5x plus 1, which is really great since those were already things I was going to have to multiply by anyway. So let's multiply both sides by x minus 4 times 5x plus 1. And let's see what happens. The first fraction, the 3 over 5x plus 1, the 5x plus 1 cancels out. So it's 3 times x minus 4. The second fraction, negative x over x minus 4. The x minus 4's cancel out, which means x times 5x plus 1. And then on the right hand side, both the factors of the denominator cancel out, so I'm left with the negative 6x squared plus 2x plus 69 up top. So now I just got to distribute and clean up. So let's see. 3x minus 12 minus 5x squared minus x equals negative 6x squared plus 2x plus 69. So we're going to bring everything to one side. It looks like, from what I like to do, I will bring everything to the left, and that will give me a positive x squared. So I'm going to bring everything to the left, so I'm going to add negative 6x squared, I'm going to add 6x squared to both sides, so leave me x squared on the left. On the left, I have 2x. When I combine those, I have 2x on the right, so they'll cancel out. And then on the left I have negative 12. I'm going to subtract 69, so I think that's negative 81. So I bring everything to the left. I have x squared minus 81. I could factor that with the AC method. I could use the quadratic formula. I could use the square root method. But I'm going to realize that factors is a difference of squares. X plus 9, x minus 9. Very oddly, you're not expecting that. So in this case, I get two answers, x minus 9, we'll solve two equations. X plus 9 equals 0, x minus 9 equals 0, so I get two solutions. X equals negative 9, x equals 9. And in that case, I'll go back to my original. Neither of the denominator factors will be made 0 by plugging those 9s, so we'll say they both work. If you ever find any issues with something I don't check, or you work and can't get it to come out, just let me know and we'll take a look at it together. I can help you find your mistake or clarify something. Or if I make a mistake, I can definitely correct it, which is always possible. Thank you.